Hello, in this video we will talk about reduction algorithms. So the reduction algorithm is an algorithm which is used to convert a matrix into row reduced echelon form or sometimes row echelon form and sometimes row reduced echelon form. So here are the steps. So the first step is to find the non-zero column. So first of all, we will find the leftmost non-zero column, and this column is usually called pivot column. And the second step is move the row with non-zero entry to the top if needed. So for example, if you have such kind of thing, here 0, here something, here something, here 0, here something, and extra. Since this is the leftmost non-zero column, and on the top the entry on the top is 0, so we have to swap the rows. We have to make it non-zero. So what we have to do, we have to swap this row with the other row. I mean, if this is non-zero, I will swap this row with this one. If this is non-zero, I will swap this row with this one. Okay, so the next step is to swap the row, or in other words, I will say move the row with non-zero entry to the top. So move the row with non-zero entry. So we have to move the row with non-zero entry to top, or in other words, we have to swap if needed. Swap. And the next step is we have to make the pivot entry 1. Okay. And the next step is eliminate all entries below the pivot. Once we are done with this, I mean, we have a matrix, we have done the work, we have made this 1, we have made here 0, all of these 0, here anything, 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 and here anything. Now the algorithm which we have done for the whole matrix, now we will need this submatrix. Okay, eliminating the first row and the first column, we will get the submatrix. Now for this submatrix, we will repeat the same procedure which we have done here. We have to find the leftmost non-zero column by ignoring this and by ignoring this. Okay, because this is the submatrix. We will find the leftmost non-zero column, and then we will swap the rows and make the top entry non-zero, and then I will make it 1, and then I will make everything below 0. Okay, we will repeat the procedure for the submatrix. Okay, so we will repeat the procedure for the submatrix below the current pivot. That means if my pivot is, for example, this is the matrix, if this is the pivot and this is my submatrix, if this is the pivot, then this is my submatrix, if this is the pivot, then this is my submatrix. So in the first step my pivot was this, in the second step my pivot was this, in the third step my pivot was this, and so on. It will be continue until we will finish the rows or the columns. Okay, now if we do this step and stop, then we will end up with a matrix with row echelon form. If you want your matrix to be row reduced echelon form, then you have to eliminate all the top entries also. For example, this is everything below is 0, and then here is something, here is 1, here is some 0, everything below is 0, and here is something, here is something, here is 1 and here is 0, then for example this is the matrix. So you have done with this thing, what you have done, you have made here 1 and make all of the things below 0. Then you have repeated the same procedure for this submatrix. You have made here 1, you have made here zeros. Then this is the submatrix, you have made here 1 and made here 0. And now if you want your matrix to be in reduced echelon form, then you will, for example, then you will use this row to make this 0 also, because we need above 0 as well. We need above 0 as well, okay? So if we need above zeros as well, so you have to do upward elimination also, okay? So you have to do upward eliminations also. Now we do upward eliminations. All right. Now we will have an example. I'll give you a matrix and I'll solve. I will convert that matrix into row reduced echelon form. So here is example, convert the following matrix. The matrix is, so this is the matrix. We have to convert it into row reduced echelon form. So here is the solution. All right, now let's look at the algorithm. The first step is to find the leftmost non-zero column. Okay, let's do the first step. What is the leftmost non-zero column? So you have this column, this column, this column, this column. So which one is the leftmost non-zero column? So this is the non-zero column because all entries are not 0. Some of them can be 0, but still this column is non-zero. So I have found the leftmost non-zero column, which is this one. Okay, so I will work, the next steps will be on the basis of this column, okay, because I have found the leftmost non-zero column. I will be focusing on this column, okay. I'll ignore these columns now, okay. So this is the column of our interest. What's the next step? The next step is move the rows with non-zero entries to the top. Now you can check on the top, the element is 0. So we have to move non-zero entry to the top. Okay? I can move this entry to the top, or I can move this entry to the top, or I can move this entry to the top. Which one is good? Okay, let's look at the next step. The next step is make the pivot entry 1. So that means if I will move this thing to the top, then I have to make this 1. So it's better to move this entry to the top, so the next step will be eliminated automatically. Okay? So what will I do? Rather than moving this to the top, or rather than moving this entry to the top, I will move this entry to the top, because if I will move this entry to the top, it will be 4. Then I have to make this 4 as 1. I have to do another row operation. So in order to reduce the row operations, I will move this entry to the top. So what to do? I will swap this row with this row. I will swap R2 with R1. So I have swapped these two rows. Okay, I have swapped these two rows. You can check from here. So I will write R1 is swapped by R2. Now look at the next step. The next step is eliminate all the entries below the pivot. What does that mean? Now this is the pivot. we have to eliminate all the entries below. This is already eliminated. I will eliminate this entry and this entry. Okay. So I have to make changes in this row and in this row. So the first two rows will be fixed. Okay. So I have written the matrix with first two row with the same as we are given in the previous matrix. And here I have to make 0. Here I have to make 0. Okay. So let's check what changes are needed in R3. Okay. In R3, the point is 4. So what to do with 4 to make 0? 4 minus something times this, because I have to use this row now because this is the pivot, times 1. What should I write here? The obvious answer is 4. Okay, so this 4 refers to R3 minus this 4 refer to the scalar and this one refer to R1. Okay, so this is the operation which I will make which will apply to make this 0. Okay, so I will write R3 minus 4 times R1. So these changes will be done in R3. Okay, now let's look. Let's make these changes in R3. So what does that mean? That means first I will write R3. So what is R3? 4, 8, 18, 2. So I will write 4, 8, 18, 2. Then minus 4. So I will write minus 4 everywhere. Minus 4 everywhere. Then R1. So I will write here the value of R1, here the value of R1, here the value of R1, here the value of R1. What is R1? R1 is 1728. So I will put 1728. Okay? Perfect. Now let's check what changes are needed for this row, because we have to make this 0 too. Okay, this element is 3 minus something times this element 1. What should be here? The obvious answer is 3. Okay, now let's check. This 3 refers to R4 because this is coming from here and this is R4. And this 3 is referred to the scalar and this 1 is coming from R1. So I will write R1. So this is the operation which I will apply to make this element 0. And these changes will be done in R4. So R4 minus 3 R1. What will I do? R4 minus 3 times R1. These changes will be done in R4. So what is that? First of all, I will write R4. What is R4? R4 is 3, 5, 14, 8. I will write 3, 5, 14, 8. Then minus 3 everywhere. I will write minus 3, minus 3, minus 3, minus 3. Times R1. So times something from R1, something from R1. R1 is what? R1 is 1728. I will write 1, 7, 2, 8. Perfect. Now I will just use calculator to simplify these things. So after simplification, my matrix will be this one. Okay, I'll get this matrix. Now go to the procedure back. What is the procedure? What's the next step? So we have eliminated all the entries below the pivot. What's the next step? The next step is repeat the same procedure for the submatrix below the current pivot. Our current pivot is this one, and we have to apply repeat the same procedure for the submatrix below this pivot. What is the submatrix below this pivot? The submatrix below this pivot is this one. Okay, now I told you previously this is the submatrix, and now we will do the same procedure for this smaller matrix. Okay, now you will forget about these things. We will assume that these things are not here. Only we will be working on this thing. Okay? Perfect. So now whenever I will do any kind of things, I will not change these things. Okay? These things are not the part of our thing. Okay, so what to do now? First I will repeat the same procedure for this matrix. Okay, now go to the algorithm again. Find the leftmost non-zero column. Okay, so what is the leftmost non-zero column from here? There are 3 columns, right? The leftmost non-zero column is this one. So we have already found the leftmost non-zero column. The next step is move the row with non-zero entry to the top. Since to the top we have already non-zero entry, so this is already done. The next step is make the pivot entry 1. Okay, we have to make this one. How can we make this one? The only possibility is to divide this row by 2. Okay, so I will write R2 divided by 2. So my new R2 is R2 divided by 2. So I will divide it by 2. Okay, if I divide 0 by 2, I will get the same. So that's why I have already written 0. So 2 by 2 is 1. Let me write 2 by 2. Then minus 1 by 2. Okay, let's write it 1. Then minus 1 by 2. And then 3 by 2. Okay, and these 2 rows will be the same. There is no change in these 2 rows. Okay, perfect. Now go to the next step. The next step is when we have made the pivot entry 1, then we have to eliminate all the entries below the pivot. Now we will eliminate these 2 entries. In other words, I will make here 0, I will make here 0. Okay, since I have to make here 0 and here 0, so that means these 2 rows will be unchanged. Okay, now how will I make this 0? And check, this is minus 20 plus some number times this 1. Of course this number is 20, right? Now this 20 refers to R3, this 20 refers to K, I will just write 20, and this one refers to R2. So this is the operation which I will apply now. And these changes will be done in R3. Okay, so it is R3 plus 20 R2. So first of all, I will write R3. R3 is 0 minus 20, 10 minus 30. 0 minus 20, 10 minus 30. And plus 20 everywhere, I will write plus 20, plus 20, plus 20, plus 20 times R2. So R2 is 0, 1, minus 1 by 2, 3 by 2. So I will write 0, 1, minus 1 by 2 and 3 by 2. Okay? Now, since we are dealing with this matrix, we have made this 0. Now we have to make this 0. How can we make this 0? I will write minus 16 plus some number times 1. And this number is of course 16. This minus 16 refers to R4, plus this 16 is constant, and this one refers to the pivot. What is our pivot? Our pivot is R2, is in R2, okay? And these changes will be made in R4, okay? That means R4 plus 16. Okay, first of all, I will write R4, and R4 is 0 minus 16, 8 minus 16, okay? Then plus 16 everywhere. I will write plus 16 everywhere. Times R2. Now I will write R2. R2 is 0, 1, minus 1 by 2, 3 by 2. 0, 1, minus 1 by 2 and 3 by 2. If I simplify these values, I will get, so I will end up with this matrix. Okay? Now, what is our current pivot? Our current pivot is this one. Okay? Again, go to the algorithm. Algorithm says whenever we eliminate all the entries below the pivot, then we have to repeat the same procedure for the submatrix below the current pivot. Okay? Since this is my current pivot, the submatrix below the current pivot is this one now. Okay? Now I have to repeat all the procedure for this matrix. Okay? This is my submatrix now. Okay. Look the same procedure for the submatrix. The first part is find the leftmost non-zero column. This is the submatrix. There are only two columns. What is the leftmost non-zero column? Of course, this one, right? So, I will be working with this column, not this column, okay? Because this is my submatrix and this is the leftmost non-zero column. Okay. The next step is move the row with non-zero entry to the top. Since this is the matrix and this is the non-zero column, and in this column we have only these two entries. So what he says move the non-zero row to the top. This means since the top entry is 0, I have to move non-zero entry to the top. Okay? What to do? In other words, we have to swap these two rows. So I have swapped these two rows here. Okay? These two rows are swapped. What I have done, R3 is swapped with R4. Perfect. Now what's the next procedure? We have done with this. Move the row with non-zero entry to the top. Now we have to make the pivot point entry 1. So since this is our column and this is our submatrix, okay, and we are working here, this is our pivot, because this is the column, because this is not the zero, this is not the non-zero, this is non-zero, and this is the pivot entry now. So we have to make it 1. How can we make this pivot 1? Of course, if I divide this row with 8, I can make it 1. Okay, I will write divide R3 by 8. So my new R3 is this one. Okay, I have divided this row by 8. So 0 divided by 8 is 0, 0 divided by 8 is 0, so 8 divided by 8 is 1. At this point, our matrix is in row echelon form. These are the pivot entries, everything below the pivot is 0. This is the pivot entry, everything below is 0. This is the pivot entry, everything below is 0. That means the matrix is in echelon form, row echelon form. If I have to convert it into row reduced echelon form, then I have to make everything above the pivot entries 0, 2. For example, above this there is nothing. Above this pivot entry, this is not 0. Above this pivot entry, these are not 0. I have to make these things 0 and these things zeros. Okay, since there is no pivot entry here, so these things cannot be made 0. So first of all, I have to make this entry 0 using this pivot entry. How can I make this 0? If I write 7 minus something times the pivot entry is 1, you know the obvious answer is 7. Okay, this means this 7 refers to R1 because it is in R1, and this minus 7 is the scalar, and this 1 is coming from the pivot, and pivot is in R2, so I will write R2. Okay, I will perform this operation first. So I have to write R1 minus 7 R2, and these changes will be made in R1. Okay, so first of all I will write R1. R1 is 1728, 1728. Then minus 7 everywhere. I will write minus 7, minus 7, minus 7, minus 7 times R2. I will write times R2. R2 is 0 here, times R2. R2 is 1 here, times R2. R2 is minus 1 by 2 here, and R2 is 3 by 2 here. If I simplify, I will get this matrix. Okay, now everything above and below this pivot are 0. Everything below this pivot are 0, but not above. Okay, I have to make this 0 and I have to make this 0. Let's look at this. How can I make this 0? 3 by 2 minus something times this pivot. This pivot is 1, and this something is obviously 3 by 2. That means R2 minus 3 by 2 times this pivot is coming from R3. Okay? Okay, I have to make changes in this row. So what are the changes? R2 minus 3 by 2 R3. So first of all I will write R2. R2 is 0, 1 minus 1 by 2, 3 by 2. 0, 1 minus 1 by 2, 3 by 2, minus 3 by 2 everywhere, times R3, okay? Times R3 is this, R3 is this, R3 here is this, R3 here is 1, okay? Perfect. Now I have to make changes in R1 also, because I have to make this 0 too. How can I make this 0? By using this pivot. I will write minus 5 by 2 plus something times the pivot. Pivot is 1. This is here, and obviously I will write 5 by 2. That means this refers to R1 plus 5 by 2 times pivot. Pivot is R3. So this is the operation which I will make. So I will apply these changes in R1. Okay, so R1, first of all, what is R1? R1 is this. 1, 0, 11 by 2 minus 5 by 2. 1, 0, 11 by 2 minus 5 by 2. Plus 5 by 2 everywhere, plus 5 by 2, plus 5 by 2, plus 5 by 2, plus 5 by 2. Now 5 by 2 times R3 everywhere. What is R3? R3 is this, 0, 0, 1. I will put 0, 0, 1 everywhere. So 0 here, 0 here, 0 here, and 1 here. Okay? If I simplify, what I get? Let's check. This is the answer after simplification. Now you can say that this matrix is in row reduced echelon form. What are the pivots? This is the pivot, this is the pivot, and this is the pivot. You can check everything above and down the pivots are 0.